What's up, guys? Welcome back to another MATLAB tutorial video. Today I'll be talking about ODEs, or differential equations, and how to solve them in MATLAB. So today we're primarily going to be working with the dsolve command. Now, dsolve command can help us with ODEs. Let me learn how to type that right. Okay. Here we go. Here's just a general. You guys can read through the help, and it gives you some examples as well as far as how to solve them, some general solutions, some particular solutions, things like that. So I feel the best way to show this is through examples, so I will be doing a few of those. Alright, first I've already typed out the first one I look at, and that is dy dt plus y times tangent of t equals sine 2 of t, and we would like to solve the general solution of this. So to do this, we incorporate our dsolve command, excuse me, and then the notation with this is something to keep into account. Dy dt is known as dy, and we also have to incorporate another thing is, don't forget the multiplication sign, because y tan of t is different from y times tan of t in MATLAB, so keep that in mind. I'm not sure, I probably can run it without 2 times t, but for this case I'll just put 2 times t to save myself to see if it will or won't, and then we're gonna just hit run and see what we come up with. Alright, so we can see that in our general solution we are going to have a constant, so we end up with c4 times cosine of t minus cosine of 2 times t minus 1. So we would need, like I said, this is general solution, and I don't want to try and teach differential equations in this video. It's more just to show off the commands and what you would do for it. So we know in the general solutions we will have constant. We need boundary conditions to actually solve for these constants. And so just for this given equation, this is how you would find the general solution. And then from there, you can potentially go and solve for a particular solution if you're given boundary conditions. Again, I'll just do another example where we're just looking for the general solution. This time it's a second order. The first one was a first order. So you can see some different types of notations. For this one, we want to do d2y, and then we want to do minus dy. Also, I've got to keep the quotes. That's another thing. And so we see with this one, we end up with a little more complex answer. And also, it's like I said, I don't want to teach differential equations, but it is noticeable that there are now 2 constants in this equation, because it is a second order general solutions, and we need we would need 2 boundary conditions for this condition, whereas with the first we would only need 1. Alright, and so now we can we'll then be able to solve for this one because it's first order and we have a boundary condition, so let's do that. Alright, and we see for this one, one thing of notice is e in MATLAB is exp, or e to the exponent of negative y for this scenario. And we also want to have a boundary condition separated with a comma. So if it was like a second order, you would have your second condition, and make sure you keep those quotes in there. So that's something to notice. And we see we're given a general solution without any constants, and it is now solved. Or this is actually the particular solution because we've solved for constants, so that means it's not general solution. So we now have solved that differential equation. Now obviously you can do this stuff in Wolfram Alpha, but sometimes it's just easier to do in MATLAB. You know, sometimes in Wolfram you'll get, I don't want to say you'll get a different answer, but sometimes it can just be easier to just see it as this, and it's helpful. So hopefully that covers ODEs. I went over a couple things as far as first order versus second order versus general solutions and particular solutions. So hopefully that covers the scope of what I wanted to get across, which it does. And good luck, guys. If you need any help, just reach out, and we'll be there for you. Thank you.